It's Mr. Potman here going over topic 2.1, light travels in rays and interacts with materials. This is a pretty good lesson. Typically in the past, we have done this as a poster project. So I whipped up this PowerPoint and I've hopefully got a fun assignment for you when it's all said and done. So that would mean no application questions, but it would be a little bit of work on you. So before we go on, let's start with a quick review of the previous section, which you should have had a quiz for. So make sure you guys get that quiz finished up. But the four properties of light, and they are light travels in straight lines. Very, very important. Has a lot to do with what we're talking about today. Light can be reflected. Also has a little bit of what we're going to talk about today. Light can bend, and lastly, light is a form of energy. Okay, so please make sure you guys know these. They will be on your quiz, especially for topic 1, which some of you may have already written. So here we go on to the next topic. Okay, so topic 2.1, like I said, light travels in rays and interacts with material. Okay, so the way light works is very predictable. Okay, so the fact that it is predictable, that's actually a very useful property. And because of that, we've been able to make a lot of different devices that make our lives easier. Okay, or we can create things that can be fun. Okay, so think of funhouse mirrors. Okay, not the one in It. Okay, don't think about that one, but think about funhouse mirrors and the way light behaves. And if you've ever been in a funhouse mirror, mirror maze and whatnot, it's really hard to get through. You can see your reflection many times when in reality you think you can turn left, you can't, those types of things. Okay, so because of that, because of the way light works, we can make things like that, as well as a whole bunch of other things like the devices we talked about in topic 1.2. In order to show how light behaves, scientists use ray diagrams. And we've got a picture of a ray diagram on the right here, where we have just a picture of a light bulb with rays going all over the place in all different directions. Okay, the arrows show the direction that the light travels. The arrow is a very important part of the ray diagram, and you're going to see that in future lessons. However, they don't show the complete picture. So again, if you're taking a look at the picture on the right here, it's just showing a representation of 1, 2, 3, 4, 5, 6, 7, 8, 9 arrows going in all different directions. But in reality, we've got millions and millions and millions of light rays. Some are shooting towards us, some are shooting away from us, up, down, left, right, all over the place. We obviously don't draw all of those. It's just a model to represent how light works. We're going to see later on, again, with the predictability of light, some devices that we can create and how they behave with certain mirrors, and we can show this all with ray diagrams. So very useful property. We can also use ray diagrams to show the intensity of light. Okay, so if you take a look at the picture again, I'll move my head there. If you take a look at the picture on the right here, we have a flashlight that's very close to an eyeball and a flashlight that's farther away from the light bulb. And I'm sure you guys have experienced this on your own. The light bulb or the flashlight, the closer it gets to you, the brighter or the higher the intensity that light bulb would be. Well, the reason being is can be shown by the ray diagrams in this image. You can see that on the bottom one here, we have 1, 2, 3 little rays. Of course, there's more of them, but for the model representation, there's 3 actually hitting the eyeball, whereas this one down here, there's only 1 because the rays diverge or they spread out. So that's a very important application of ray diagrams. So which would you think is brighter and why? So obviously the closer the light bulb is, or the ray, or sorry, the light bulb or the flashlight is to the eyeball, the brighter it's going to be because there's more rays actually hitting the eyeball. So very good representation of a ray diagram. Why isn't this working? There we go. Shadows can also be shown with ray diagrams. Some of you might remember this from from grade 6 when we talked about shadows and seasons. Maybe it was grade 5, I can't remember. But ray diagrams can help explain the formation of shadows. So here we've got a gentleman standing close to a light bulb, and the ray diagram shows the light bulb, the light shining in a whole bunch of different directions. However, some of it's shining this way, and it's hitting the man standing there. So that's actually blocking those light rays. So any rays on this side, they're blocked from the individual. So you can see that the light rays continue off and eventually it'll hit a wall and that'll create a shadow. That's part of the assignment you guys will be having coming up here. Okay? So they're formed by the blocking of light rays. If the object is, if the object creating the shadow is close to the light, so the closer we bring it to the light, the more light rays are going to be that are hitting the individual. So the other light rays are going to end up by spreading or diverging more, and the shadow will end up by being larger. The opposite is true the farther away. If we were to move this gentleman further or closer to the wall, the number of light rays hitting him would be less, so the shadow would end up by being smaller. Light also interacts with material. Here's another fun part you're going to be having. The type of material affects the way light behaves. Okay, so we have transparent material. Transparent material is material that allows light to travel straight through them. We've got them all over our house. Okay, think of looking through a clear window. You can see through a window because it's transparent. Same thing with cling wrap or saran wrap. Those are clear. Clear lucite or clear plexiglass, those types of things. It's all clear. Light travels right through it. Okay. Translucent material allows some but not all of the light through. And we have these in our houses as well. So think of the frosted glass on a pantry door. I know some pantry doors, they have the word pantry written on it, and then it's got frosting all around it. Okay, or they have something called a glue chip, which is actually has chips of glue. Uh, Glued onto the window so it makes it not really see-through, or washroom windows. You may have windows in your washroom where it's all frosted so that the outside cannot see. Still allows the light through, and if you were to put your hand right up against it, you'd be able to see the shadow or the imprint of your hand. Another good example of a translucent material is leaves or our leaves. If you take a look in your textbook, I believe there's a picture of a bug on a leaf and the sun shining down. You can see the bug on the other side of the leaf. Okay, and lastly, there's opaque materials, and opaque materials don't let any light through them. They absorb or reflect all of the light that actually hits them. So think of your textbook or my little mouse here, right? The light doesn't shine through the mouse. Okay, it actually gets absorbed or is reflected off of it. Light sources are the next thing we're going to talk about them. You guys might remember from topic 1.1, we talked about how Al Haytham stated that we can see objects because light from some source around anywhere, could be a lamp, could be the sun, bounces off the object. From there, it bounces off the object and then reflects to your eye. That allows us to see. So that's different than what Mr. Pythagoras thought, where the light came from our eyes. Al Haytham said the light came from other sources. Okay? The objects we are seeing, again, calculator right here, calculating averages. The reason I see this calculator is because the light is bouncing off of it, not because the calculator itself is producing light. And those objects that don't produce light are called non-luminous. Okay, so they're non-luminous objects, meaning they don't generate their own light. And that could be a pencil, a table, or even the moon. The reason we see the moon is because the light from the sun hits the moon and then bounces back to our eyes. Objects like the sun and a lamp or a light bulb or anything along those lines that produce light, those are known as luminous objects. Okay. Next thing we're going to talk about is types of reflection. Okay. There's two types of reflection, but when you think of reflection, when I think of reflection, I typically think of looking at myself or looking at something in a mirror, maybe looking at a nice clear lake where you're seeing the reflection of the trees off of the lake. Okay, typically when you think of reflection, when I think about it, that's what I think about. Okay, when light rays hit a smooth surface like a mirror, okay, the reflecting rays all bounce back or bounce off at a similar angle or the same angle. That's called regular reflection, and we have it over here on the right. If you take a look, we've got 4 light rays all coming in. Okay, coming in towards the mirror, and they're all bouncing off parallel at each other. Okay, so they all bounce off at the same angle, all parallel to each other. Regular reflection produces a clear image, but this is pretty important, you must be in the direct path of the reflected rays in order to see the reflected image, okay? So that's why if you're ever looking at something in a mirror, let's say you're looking at somebody else in a mirror, okay, they can actually see you too, because all the light rays are bouncing back straight. If the light rays are bouncing from the mirror back to me, and I'm looking at an image that's in the mirror, that image in the mirror, if it's another person, they could see me as well. Those light rays are all bouncing back straight. Okay. However, when light rays bounce a rough or an uneven surface, okay, and this rough, uneven surface could be something really rough and uneven like my jacket, or it could be something like a countertop, which would seem smooth, but if you look at a microscopic level, it is rough. Okay, you get something called diffuse reflection. And you can see that again on figure 2.8 over on the right here. Okay, diffuse reflection occurs when the light rays do not reflect off the surface. When they do not reflect off the surface at different angles, and thus they don't remain parallel. Okay, so they're bouncing all over the place. So this one right here is coming in here and it's bouncing out that way. This one is coming down here and it's bouncing over this way. Okay, because the light is scattered all over the place, you actually see objects. You can see objects from any position. So think of your countertop. I'm looking at my countertop right now. I'm not going to show you because it's really messy, but I can see it's a brown countertop, and that's because the light is the rays are reflecting all over the place. So here we go. Here's the assignment for this class. No application questions, but a little bit of work on your end. Okay, we're going to use an application called Flipgrid, and I'll have the instructions on D2L. You'll probably have to download an app. If you don't have the app, if you can't download an app, you can use the camera on your computer. If you can't do that, don't worry about it. We'll figure out another way around it. Okay, but you're going to be doing 4 things for me to show the principles that were in this lesson, as well as in topic 2.1 in your textbook. The first thing you're going to do is using Flipgrid or another video sharing app. You're going to sharing app, I should say. You're going to make a video showing the following. First thing, I want you to show me some shadows. I want you to make some sort of shadow performance. So making birds, shadows of a bird flying or something on the wall, or a little bunny rabbit hopping through the meadow. Okay, show how the shadow grows and gets smaller as you move closer and farther away from the light. You should be able to do this on your own, but you might need to have somebody else help hold the camera. It works very well with your Chromebook or laptops as well. Okay, I also want you to show me a comparison of transparent, translucent, and opaque objects just around the house. Okay, don't overthink it. Okay, it could be very, very simple and very, very straightforward. Something that allows all the light through, transparent. Something that allows some of the light through, translucent, and then opaque. Next one, show me a comparison of a luminous and a non-luminous object that's in your house. Again, shouldn't be too hard. Don't overthink it, but have fun with it. Take risks with it. And I also want you to show me a comparison of regular and diffuse reflection. This one might be a little bit harder to show, but it's really not. Okay, I was contemplating making you just show me a couple of these, then I thought, nah, forget it. You guys are creative. You can show me all of them. Okay, and then that is it. That is it for this this assignment. Okay, it can be submitted via Flipgrid. Okay, today's lesson is a Monday. Okay, I'm going to give you guys tomorrow to play catch up on this lesson and the other 2 lessons I gave you prior to the Easter break. All of this stuff is due Wednesday. Okay, remember my rule, my unwritten rule. I'm not breaking St. Martin's rules as far as making sure assignments due dates. They are still due on Wednesday. However, I will obviously accept them one day late without me harping on you and sending emails home. So that's my unwritten rule. But the due date is next Wednesday, so you guys will have not next Wednesday, but the Wednesday after Easter break. I have created some drop boxes, but like I said, this should be submitted via Flipgrid. But if you can't do it through Flipgrid, I have some drop boxes on D2L, just general submissions. Feel free to send it there. Of course, it's an individual assignment because we're all on home isolation and whatnot. But if we were not being forced to isolate on a normal day, I'd probably let you do this as a group assignment. So unfortunately, you all are going to have to do your own. If you have any questions, please email me or yeah, I guess that's the way. Email me, message me, and we can discuss this lesson's activity. All right. Have a great day. If you watch this before Easter break, have a great Easter break. We'll see you guys later.